Hey, welcome everybody. These are extremely exciting times. This is what will be the third most important lesson in geometry. It's second after Pythagorean theorem right now, but it'll hold strong through the end. Bear with me. I'm outside. It's a lovely spring day. I know some of you have some allergy issues, and I hope those things don't bother you, or the bird noises or whatever other fun stuff that we hear. All right, this is about special right triangles. There are two types of special right triangles. Every other one is apparently not special. The first type that we're going to look at is called a 45-45-90, or an isosceles right triangle. If you have two congruent sides, you have two congruent angles. Those two congruent angles will have to be 45 degrees. So we call it a 45-45-90 triangle, or an isosceles right triangle. An isosceles right triangle. Excuse me. So I'm going to derive this formula. You don't have to recreate this on a quiz or anything, but I want you to see where this comes from. If the two legs are congruent, I call them both x. The hypotenuse is c. I can use the Pythagorean theorem. I can combine like terms. I can take the square root of both sides. The square root of 2 is the square root of 2. The square root of x squared is x. The square root of c squared is c. What I'm showing right here is that c, the hypotenuse, is equal to x, a leg, times the square root of 2. That's basically a formula that will always happen. The hypotenuse is the square root of 2 times as long as the leg. And vice versa. So yeah, you'll definitely want to write this down. If you have a 45-45-90 triangle, we're always either going to be going from the legs to the hypotenuse to the legs. If we're going either way, the magic number is the square root of 2. You multiply to go from the legs to the hypotenuse to go bigger. You divide to go from the hypotenuse to the leg to go smaller. That's the lesson, basically. It's important to note that a 45-45-90 triangle is half of a square. That is always, always, always the case. So squares are all about 45-45-90 triangles when we're talking about a diagonal. Okay, so if you're given a leg of an isosceles right triangle, are you going to go from, if you're trying to find the hypotenuse, are you going to go bigger or smaller? Well, the other leg is the leg. How are you going to go bigger? Yeah, the bigger you multiply. So you're going to say the hypotenuse is 7. The magic number is square root of 2. 7 times the square root of 2 is 7 times the square root of 2. That's it. Example B. If the leg is 5 square root of 2, the other leg is also 5 square root of 2. They both are. You're going from the leg to the hypotenuse. The magic number is the square root of 2. You are multiplying. 5 square root of 2 times the square root of 2, well, is 5 times 2. The square root of 2 times the square root of 2 is 2. And we get 10. We're done. That's it. If one of the legs is 2 square root of 10, the other leg is also, of course, 2 square root of 10. To go to the hypotenuse, we're getting bigger. We're multiplying by the magic number of the square root of 2. So this becomes 2 times the square root of 20. Why did we build up to tear down? But the square root of 20 is 2 square root of 5. That simplifies. So we have 2 times 2 square root of 5, which simplifies, becomes 4 square root of 5. That was the harder one, sort of. That's basically it. The other example I'm going to give to you, what if we're going the other direction? If we're going from the hypotenuse, if we're starting at the hypotenuse, to go the other direction, the magic number is still the square root of 2, but we go divide. We will divide by the square root of 2 instead of multiply. 6 square root of 2 divided by the square root of 2. The square root of 2's cancel out. We're left with 6, and we're done. That's both legs. Isn't that awesome? This one's going to get uglier, but it's just as simple process-wise. We start off with the hypotenuse being 11. Will we multiply or divide to go from the hypotenuse to the leg? We will divide by square root of 2. Simplify. Ooh. Radical on the bottom. Got to fix that. So we multiply by the square root of 2 over the square root of 2. We get 11 square root of 2 over 2. 11 over 2 does not reduce. That is a simplified answer. It's a little bit ugly, but it's simplified. That's it. What if the hypotenuse is 2 square root of 10? Will we multiply or divide from the hypotenuse to the leg? Bigger to smaller, we divide by the magic number, square root of 2. The two numbers that are inside the radical, the 10 and the 2, they will divide. 10 divided by the square root of 2 equals 2 square root of 5. And that's it. That's it, y'all. At least for 45-45-90. I'd like for you then to try to fill in this table. This is basically all of these 1 through 8. Actually, do 6 of these 8. All of these are using this diagram. The legs are A and then B. So an A and B are equal. C is the hypotenuse. Sometimes it gives you the leg, sometimes it gives you the hypotenuse. Fill in 6 of those. Go. These are answers. Be prepared to ask questions when you have them. Those are answers again. The other special right triangle is called a 30, 60, 90 triangle. It's got a little bit more going on because it's not isosceles. I'm going to derive this formula using something that has a 30, 60, 90 triangle built within it. That being an equilateral triangle where all of the angles are 60 degrees. Okay? If I drop an altitude in an equilateral triangle does special things because it's not just an altitude, it is also a median, it is an angle bisector, it is everything, an altitude, a median, angle bisector, a perpendicular bisector. My goodness, it's busy. Here's what I'm going to do. I'm going to do this very strategically. I'm going to call this part of this triangle A, so that this part of the triangle is also A, which means that when I put them together, I get 2A, which means that this other side is 2A and that other side is 2A because, well, it's an equilateral triangle. That was very strategic on my part. I'm going to call the altitude in this case B. Here's what I'm going to do now. I'm going to split off that triangle so that I have A, 2A, and B, where 2A is the hypotenuse, A is the short leg, opposite the 30 degrees, and B is opposite the 60 degrees. I'm going to go apply the Pythagorean theorem. Oh, I don't have, well, first, no, sorry. The altitude, the hypotenuse rather, is twice the short leg. That's a thing. The hypotenuse is twice the shorter leg. Now I'm going to apply the Pythagorean theorem. When you square 2a, you get 4a squared. Okay? I'm going to subtract a squared. Again, you're not going to have to recreate this, but this comes from somewhere. B squared equals 3 square root of a. That's 3a squared, rather. Now I take the square root of everything. The square root of b squared is b. The square root of 3 is the square root of 3. The square root of a squared is a. What I have now is that the short leg a is equal to, the short leg a times the square root of 3 is equal to b. So what you're going to have to know here is that we always go through the short leg. The short leg is the key. We will always use it. I'm going to try to simplify this up here with you in this chart that I'm creating here. It's in between the pages on here. You might want to write it on the back of the other page so you can use it. But this is what you're going to have to know. You have the short leg, and you have the hypotenuse. The magic number from the short leg and the hypotenuse is 2. You multiply to make it bigger, you divide to make it smaller. The short leg to the long leg, the magic number is square root of 3. If you're going from the short leg to the long leg, you multiply by the square root of 3. If you're going from the long leg to the short leg, you divide by the square root of 3. That's kind of it, y'all. That's kind of it. I mean, seriously, that's kind of it. Everything else is just simplifying. Like, watch this. This next set of examples. When it gives you the short leg is 9. If you're going to go from the short leg to the hypotenuse, you will multiply by what? 2. 9 times 2 is 18. Bing, done. If you're going from the short leg to the long leg, you'll take that short leg. You're going from the smaller thing to the bigger thing. You multiply by what number, magic number? The square root of 3. Y'all, this just becomes 9 square root of 3. Boom. If the short leg is the square root of 5, the hypotenuse, you're going from the short thing to the longer thing. You multiply by what magic number? 2. Square root of 5 times 2 is 2 square root of 5. That's it. From the short leg to the long leg, you will multiply by what magic number? Square root of 3. The square root of 5 times the square root of 3 is the square root of 15. That is simplified. If you're paying attention right now, just write at the top of the page. Boom. Thank you. All right. If you're given the hypotenuse, well, will we go from the hypotenuse to the long leg? Well, not directly. We'll always go to the short leg. Well, how will we start this? To go from the hypotenuse to the short leg, we divide by 2. The short leg is 10. To go from the short leg to the long leg, we will multiply by 3. 10 times the square root of 3 is 10 square root of 3. That's it. That is it. This next one's going to look a little uglier, but the process is the same. If our hypotenuse is the square root of 10, we go from the hypotenuse, divide by the square root of 2. I'm sorry, I said that wrong. Divide by 2. Square root of 10 divided by 2 is a simplified expression. There's nothing else to do here. We're done. To go from the short leg to the long leg, not quite done. We have to multiply by the square root of 3. This one's uglier. It's not necessarily harder. Square root of 10 over 2 times the square root of 3 over 1 gets us square root of 30 over 2. And we're done. Okay, so some of these get ugly. I hope you don't see them as hard. What happens if you start with a long leg? Well, you'll always go to the short leg. The long leg, will we multiply or do divide to go from the long to short? We will divide. Now, this one's really ugly because 14 over 3 is just going to be ugly. But we got to multiply by the square root of 3 over the square root of 3. Square root of 42 over 3. They will not always be ugly like this. Just wanted to show you that they're not always pretty. But that's simplified. Square root of 42 is 2 times 3 times 7. Nothing comes out. The hypotenuse, we multiply by 2. That becomes 2 square root of 42 over 3. Ugly, hopefully not hard. Okay? The next one is going to look a lot prettier. If the long leg is 9, to go from the long leg to the short leg, we divide. Long to short, we divide by the magic number square root of 3. So 9 divided by square root of 3 becomes square root of 3 over square root of 3. 9 square root of 3 over 3. That reduces 3 square root of 3. Hypotenuse, we take that short leg, which is now 3 square root of 3, and we multiply by 2, we get 6 square root of 3. Once you go the short to the hypotenuse, you multiply by 2. 2 times the short hypotenuse. People, that is it. This chart's like the one on the front. Pause the video. I just gave you the answer to the first one. That's a bonus. Do 5 of these other ones, 10 through 16. Check your answers. Those are the answers. The rest of this is just, well, picture examples. Some of these got 2 and 1, like here and here, 2 triangles combined. But when you see this number, 45 degrees, or 60 degrees, or 30 degrees, you're going to use the square root of 2, or square root of 3 to get to the other sides. We don't have to use the Pythagorean theorem. See if you can do 4 of these, 2 of these, and both of these, please. We will talk so much more about this in class. These are the answers to these questions. This will become super easy. It will need to. And yeah, get some rest. We got a lot to do. Okay, bye.